Hi, I am Neeta Sharma from Brain League Learning. Let us explore what entropy is, and then solve a simple heat transfer example together. Think of a tidy stack of books where everything is in order. Now knock them over, and they fall into a jumble. That jumble is higher disorder. In science, we call this disorder entropy. In thermodynamics, for a tiny reversible heat transfer, delta S equals delta Q sub rev divided by temperature T. Reversible means the change is done so slowly that the system stays balanced. Here is our example. A hot object at 400 Kelvin gives off 200 joules of heat to a large reservoir at 400 Kelvin, and it is reversible. We will find the change in entropy of the object, the change in entropy of the surroundings, and the total change in entropy. First, the object loses 200 joules, so Q sub 1 equals negative 200 joules at temperature 400 Kelvin. The change in entropy of the object is delta S sub 1 equals Q sub 1 divided by T sub 1, which equals negative 200 over 400, which is negative 0.50 joules per Kelvin. A negative value means the object's entropy decreases. Next, the reservoir gains that same 200 joules, so Q sub 2 equals plus 200 joules at temperature 400 Kelvin. The change in entropy of the surroundings is delta S sub 2 equals Q sub 2 divided by T sub 2, which equals plus 200 over 400, which is plus 0.50 joules per Kelvin. Finally, the total change in entropy is the sum. Delta S total equals delta S sub 1 plus delta S sub 2. Adding negative 0.50 and positive 0.50 gives 0 joules per Kelvin. That is exactly what we expect for a reversible process at constant temperature. In plain words, the heat lost by the object is exactly the heat gained by the reservoir. Because it is reversible, and at the same temperature, their entropy changes cancel out. Thanks for watching. I am Neeta Sharma from Brain League Learning. Remember to like, subscribe, and keep learning.